Hello all, and thank you for joining us today on this session titled Architecting for Sustainability with our speaker, Mr. Tarek, who is a Senior Partner Solution Architect at Amazon Web Services. Mr. Tarek's expertise concerns alignment between data, architecture, and agility. I give you the space, Mr. Tarek.
Thanks so much. Welcome everyone to today's session. As our great host mentioned, my name is Tarek Kaddoumi. I'm part of the worldwide public sector team here at Amazon Web Services. I work mainly in enabling and in empowering partners toward being and having a great success stories and success partnership with AWS. In today's session, I'm going to take you through what we call here at AWS architecting for sustainability, which is one of the very critical subject and let's say topics that are very important and hot ones today in light of the importance of the sustainability and having our architecture and architecting practices aligned in a way that we take the sustainability into our consideration and our best practices. What I'm going to discuss with you today is I'm going to give you some use cases related to the sustainability. What do we mean with sustainability from a solution architecture perspective? What are the best practices that we're looking for as we are going to do our solution architecture? How can we measure the alignment and the friendliness of our solution architecture with the sustainability best practices, and how can you get started with all of this for sure? So without further ado, I'm going to start by taking you through few use cases for the sustainability. For sure, we're all here. I hope that we're all aware about the, let's say, general perspective and the general perception of the sustainability, where it is about having a society understanding of this protocol. Based on the understanding of this protocol, we can take into consideration that the protocol has 3 scopes. So the GH protocol has 3 scopes in order to measure and in order to assess the greenhouse emissions. The first scope is the fuel consumed, which is about the direct emissions, the direct gas emissions. We're talking here about fuel, we're talking about wood, anything that can be burned and that can emit greenhouse gases. In order to reduce this, we would like to have a goal to electrify anything, to electrify all the workloads that we work on, to have the electricity enablement of our workloads in order to be able to reduce and the consumptions of the fuels and for sure the emissions. At AWS operations, this is one of our main goals, and we are working intensively on moving into electrified power generation. The second scope that the protocol is involved in is the emission that comes from purchased electricity. So yes, the first goal is to move from pure fuel workloads into the electricity-based workloads. However, we are still within the scope to looking into to address the emission that comes from the electrified power generation, because for sure, if you electrify anything, there will be energy that have a carbon intensity, because the energy is usually still created by multiple sources. I'm talking here about wind, solar, coal, all of these types of emission that we need to take into consideration to reduce the emission out of the purchased electricity. We have to use much renewable power as possible as we can from the grid instead of the electricity itself. And this is again another goal for AWS at its own electrical power and facility. The scope mainly depends on everything that can indirect emissions from up and downstreams of the businesses and our supply chain. So it's not about the pure fuel, it's not about the electrified workloads, it's about anything that can produce. It depends mainly on the production depth, it depends on the goods and the services that you are involved in. And yeah, with this, you can see that the protocol addresses these three scopes that I just introduced you to. How AWS can help you to address your need to enable and function and leverage such protocol. We at AWS have what we call it the AWS Customer Carbon Footprint Tool, which is a tool released last March 2020, and that provides customers and partners for sure with the with the protocol data and the protocol related data in form of metrics that provide the CO2 equivalency of the greenhouse gases emission for scope 1 and scope 2. Again, for scope 1 and scope 2, because the protocol is still working on providing metrics related to the scope 3. We have now what we have metrics for scope 1 and scope 2 only. We're looking at how can we, and AWS working with the organization in order to look into ways how can we measure the scope 3. However, for the time being, the AWS Customer Carbon Footprint delivers the metrics in form of these in form of this tool for the scope 1 and scope 2. As you can see, with this tool, you can see your carbon emission out of you based on your workloads hosted at AWS month by month, starting from 2020. It's going to be broken down into geography, and it's going to be broken down into services. With this, you will be able to understand your emission in form of CO2 and your participation into producing the greenhouse gas into the environment. I'll give you a snapshot of this tool and what type of data that you can expect. As you can see here, this tool have here the data range from what date to what date you want to see your carbon footprint, and what is the data and the metrics related to your carbon footprint metrics, and what are the savings that you've been able to achieve based on your best practices related to reduce the carbon footprint and reducing the greenhouse gas emission. From my personal perspective, I guess that this is a very, very important tool for all customers, for all partners, in order to be able to have an asset in hand toward the journey of having more sustainability friendly workloads on AWS. I'm going just to make a note that I'm super happy to take any question during the session, and if you feel free to interrupt me by voice, by asking questions by voice, and if you want to chat, to drop questions on chat, I'm super happy to answer them. Moving forward with our session, it's very important to know that we at AWS are so serious about taking the carbon reduction seriously and critically, and it's been reported that having the workload hosted on AWS compared to any other data centers in the world will provide you and the environment and the society with a remarkable, what we can say, remarkable kind of benefits in terms of carbon reduction and so on. So based on too many benchmarks and studies and analysis, hosting your workload on an AWS data center 3.6 times more energy efficient workload to compare to the data centers hosted in the US. And it's going to give you 5 times more energy efficient workloads compared to Europe and Asia Pacific. All of this shows you the opportunity to reduce the carbon footprint and to have more energy efficient workloads by hosting your workload on AWS. Another use case that I just mentioned, talking about the sustainability services, you're still involved in a supply chain and a distribution chain. And for this, we are at AWS enabling our customers and enabling the organization that's willing to take the responsibility of the sustainability by giving them opportunities to have sustainability data sets in an open format way. And these sustainability data set and helps you to understand and optimize the whole value chain that you have by being able to benchmark your data. As you can see here in this diagram, this is your business and this is your workload on AWS, and this is your practices with your supply chain and your distribution chain. And you're interested in understanding, is there anything else that I can do toward overall sustainability goals? For sure, there are always chances in order to improve your supply chain and your distribution chain, let it be physical or digital. And with this, we provide you with the sustainability data set in order to be able to achieve these goals. Moving forward, it's not only about the sustainability data sets. We provide our customers and our partners with multiple programs in order to help them toward their sustainability responsible, let's say, workload architecture and practices. And with this, I'm going to name, just for your reference, the following programs. Open Data Program, it makes high value and cloud optimized data sets publicly. Yes, in order to let you work with data providers in order to democratize and in order to access the data by making it available to the public for analytics, for doing your analysis and being able to compare your workloads with other workloads and with benchmarking data. The second program that we have called Amazon Sustainability Data Initiative. And the mission of this program is to reduce the cost, the time, and the technical barriers to extracting the knowledge and the insights from the large data sets. And with this, using AWS and scalable infrastructure and associated computational services, you will be able to address this problem. The third program, which is the data exchange, is a program that can help you in order to consume a AWS managed service that can help you with exchanging the data, first of all, to finding the data, to subscribe to the data, and to use the data in the cloud. With this, you will be able, in order to achieve the sustainability and having your data sent or receiving data from the Open Data Program or from the sustainability data initiatives and all of these. These are three programs that are there, provided by AWS, in order to help you through achieving your responsibility toward your sustainability practices. Moving forward, I guess that with this, we covered the part of the sustainability from, let's say, carbon footprint reduction and in relationship to the use cases that we have in hand, and in order to measure and to assess your practices and sustainability and your technical practices and solution architecture. However, moving forward, I want to move into the details of the architectural best practices that you can have in mind in order to have your technical and solution architects team more sustainability aware, acknowledged, and enabled, and for sure functioning toward better sustainability workloads. Start first with introducing you to what we call it the AWS well-architected framework. There is a chance that it was mentioned in other presentations with other colleagues, but however, I'm going just to take you through this framework very quickly. First of all, the well-architected framework is a set of best practices and gathered and presented by AWS from the long history that we have had here at AWS working in solution architecture. It's a set of best practices distilled in a set of open questions designed to help you ensure your workloads meet your needs and take advantages of the best practices. The well-architected framework comes in form of 6 pillars. Actually, it used to be 5 pillars. As you can see, the last pillar, which is the sustainability one, has been introduced recently. So let me take you through these pillars and what we mean with each one of these pillars in this well-architected framework. So first pillar out of these 6 pillars that we have here is the operational excellence. And with this, we are talking about how much your solution architecture is aware about the operational excellency, what type of metrics what type of the best practices you need to take into consideration, and this type of consideration. Security, how secured is your solution architecture? What type of, how in terms, for example, we're talking about authentication, authorization, encryption, and all of the security-related workloads or practices. Reliability, how much your customers and your workload participants or consumers can expect your solution to be reliable. What type of workload, what type of design decision you're making toward this, for sure, talking about high availability, redundancy, load balancing, and all of these types of architectural best practices. How performant is your workload? We're all concerned about the performance of our workloads from customer or vendor perspective, and this is the 4th pillar of the well-architected framework. And for sure, the fifth pillar here that we have is the cost optimization. And as you can see, we are also concerned into have friendly workloads, and we deliver our customers within the well-architected framework with the practices and questions and the observation and the best practices and advices in order to have cost-friendly and cost-aware solutioning and best and architecting. However, in addition to these 5 pillars in this well-architected framework, we have the sustainability pillar, and we are pushing toward having the solution architecture best practices as adopted and as advised by AWS to be more aware of sustainability, and how can we move our technical and solution architecture decisions and preferences toward having more sustainability friendly and aware design. Moving forward, I'll give you I'm going to deep dive with you into the sustainability pillar. As you can see, under the sustainability pillar, we have what we call the shared responsibility model, and I'm going to give you a bit of the idea about it. We have the design principles, we have improvement process, we have trade-offs, and we have best practices. If we move forward and in this session, I'm going to highlight with you the shared responsibility model and the best practices. I invite you to go to AWS websites to look up to look up the well-architected framework and to look under the design principles and the improvement process and the trade-offs. Just for the sake of the time management, I didn't include them in this session. However, each pillar under the well-architected let's say sub-elements, I invite you to go and read them. They are really, really, really important, and they will add a lot of value and insights to your awareness about the sustainability. However, as I told you in this session, I'm going to take you through the shared responsibility model and the best practice. Let's start with the shared responsibility model. First of all, what is the shared responsibility model? The shared responsibility model is something that hasn't started on with the sustainability practice or with the sustainability conversation. It was here since we started engaging with our customers on security discussion, and later on compliance discussion, and recently on sustainability discussion. What I mean with this, the shared responsibility model as a concept is about identifying the mutual responsibility between AWS and customers toward a specific topic, as I said, security, concept, compliance, and sustainability. As you can see in this model here, we have the cloud, And the question is, who's responsible of the sustainability of the workload in the cloud? And as you can see, it's not AWS alone, and it's not the customer alone. The green, let's say, activities or tasks or actions to be done on the cloud, in the cloud, sorry. The green ones are the responsibility of AWS because they are the sustainability of the cloud. So AWS is responsible of the security of the cloud, the compliance of the cloud, and the sustainability of the cloud. What I'm talking about here is the sustainability of the servers, how energy efficient they are, the cooling used in the data centers and for the development and the servers that we have, the water and the cooling. How do we treat waste? How do we do waste? And how do we maintain and dispose waste? This applies for the data centers, for electricity supply, for the building, and for the whole global infrastructure that AWS owns. On the other side, as you can see at the top of the model itself, you can see that the customer is going to be the responsible of the sustainability of the data design and usage, the software application design, the platform deployment and scaling, the data storage. How, as a customer or as a developer, as a partner, as a consumer of AWS platform, how am I going to store my data? What type of decisions that I'm going to take when I'm going to make my design in order to store a huge set of data? What type of code efficiency I'm going to follow? And I know that there are maybe 1 or 2 sessions about coding for sustainability in this program. The utilization and scaling, how am I going to scale my workloads? Am I going to scale it without any, let's say, predefined metrics assessment or analysis? Am I going to just scale and scale and scale and regardless of the workload that I'm really concerned of? These are the things that you as a customer or as a consumer of AWS services, you will be in charge of when we're going to identify the responsibility model of the workloads on cloud. Moving forward with the initial understanding of the sustainability model, as you can see here, every team should own sustainability goals. Invite you and your teams and the other teams to start assigning sustainability goals to your technical team. So for example, a senior leader of sustainability, let's say, unit should report the carbon data of the organization of the enterprise, while the architect or the developer should be designing their workload and their solutions, taking this sustainability into the mind. Developer DevOps, the developer and the DevOps engineers, efficiency of their code. How much of the computing power they're going to consume with their code and with their decision into delivering their DevOps stacks or deployment deliverables or packages and so on. These are the goals that we can have in mind when we talk about assigning goals for our teams. However, our teams should be always enabled and supported with architecture patterns in mind in order to be able to design for sustainability and optimize for efficiency. What I'm trying to say here is that I count all architects, developers, engineers, DevOps engineers, database, whatever engineers, to have goals towards sustainability and environmental sustainability, as I said, without supporting them with the right architectural patterns that they can take into consideration when they want to move forward with their technical decision and design decision. And as you can see in this slide, we identify as AWS 6 architectural patterns in order to support your teams, including architects, designers, developers, engineers, and so on, with their technical decisions. Those architecture patterns are the region selection. By the way, I'm going to talk about each one of them in details. The region selection, the user behavior, the software and the architecture, the data, the hardware, and the development and deployment. Let me start with the region selection. As you can see, we have 26 regions with 84 availability zones. And we have also more regions to come on the way. And each of these regions, the majority of these regions will be enabled and supported with what we call it renewable energy projects. And as you can see here, we have 274 renewable energy projects worldwide. As you can see, we have 30, sorry, we have one, two, so we have 64 in America, we have 33, we have Kenya, including portion, and the recent introduction to India, and this one is the South Africa one, and we have 7 ones in APAC. As you can see, the global infrastructure with the renewable energy projects can support you with taking into consideration what region you should decide to host your workload on when you make your decision, when you make your solution architecture decision. Too many regions covering the whole globe, supported and enabled with the renewable energy project, and you can just make your decision in order to pick the right region that can serve your sustainability goals. The second architecture pattern is the user behavior pattern, and here what I'm talking about it is the user behavior is about, for example, the peak in demand on a specific application. For example, how are you going to design your solution in order to address the infrastructure scalability while user load? Well, how are you going to design your SLA with your sustainability goals? How are you going to, for example, eliminate the addition or the reduction or or how are you going to eliminate creation and maintenance of unused assets? For example, having 15 EC2s in your account just running without any usage. What type of decision and what type of criteria you're going to adopt in order to optimize the placement of your services and the instances of your services across the geographical options that you have? And how are you going to enable your team in order to optimize their resources for better performing activities? For example, you need to identify what we call it the SLA for sustainability goals. What are your SLAs whenever it comes to negotiate impact-friendly workloads? For example, you need to look into your SLAs with the multiple stakeholders or the multiple teams that you have in your organization or your enterprise. You need to understand how the adjustment and the refinement of this SLAs can reduce your cost, because the better SLA, the better performance, the better result, the better cost reduction. You need to communicate the message with your SLA stakeholders that small adjustments into your SLAs will have, for sure, huge impact in reducing the overall impact. Okay, and in addition to this, we have what we call it the optimization of our. So for example, we need to have the user behavior of our teams in the organization aware of the options and the possibility available at AWS in order to support them in multiple workloads. For example, when you want to do data transformation, consider ETL as a service. Consider doing your data extract, transform, and load on cloud, instead of provisioning on-premise server or servers or cluster of servers and procuring multiple devices and multiple, let's say, supporting for this on-premise servers in order to do your data transformation. Consider the AWS Glue, which is a ETL as a service provided by AWS in order to help you to achieve your ETL exercise on demand without in a serverless pattern. And for sure, you always pay for as you go. When it comes to data visualization, again, instead of provisioning resources and going for any solution on-prem, we have Amazon QuickSight, which is a completely on-demand, serverless, scalable, highly performing visualization service provided by AWS. If you're looking for a virtual desktop, we have Amazon Workspaces, and if you're looking for virtual production, we have Amazon Nimble Studio. So the user behavior is a very critical and to be considered by you while you are trying to apply the right architecture patterns into your organization. Moving forward, we have what we call it the software and the architecture patterns, which can help you in order to optimize the software and the software design decision for its asynchronous, for queuing, for scheduling, and it can help you to make a decision whether to remove or whether to refactor workloads because of your analysis of the usage of these workloads, whether they are in a low usage mode or they are not used at all, but you're considering keeping them for a reason. This will help you also to optimize the area of your code that can consume a lot of resources. Please consider always that code is a huge factor into the, let's say, sustainability responsible solution architecture, because the code is going to drive a considerable part of power consumption and power efficiency. In addition to this, you can also use the storage pattern. Moving forward, you need to keep in mind that ability goals, scheduling and taking into consideration the workload is not always the right way to consider your real consumption. For example, as you can see here, we have this demo of curve that shows you the resources used by an application. As you can see, the average usage here can be well understood based on this average curve. However, we have multiple peaks in the curve. The total, the impact depends on the total provisioned capacity. So, for example, if your EC2 fleet is on average here, however, the fleet stopped because of a peak of demand or whatever at a multiple points into your timeline and into your curve, this will lead for sure to have the total provisioned capacity impacted and increased. While if you look into your software and architecture, your software and application development patterns, in order to get rid of these peaks, you will be able to relate the total provisioned capacity to the average. So for example, now let's consider the scenario where you're able to drive the peaks down. If you remember in the last slide, we had multiple peaks on the curve. If you were able to get them down, either because you were able to distribute the workload over the whole curve, or because you implemented a queue to smooth the load that you have into your design, you will be able to get rid of these peaks, and your average will be able to represent and to reflect your total provisioned capacity and the impact that you might have. Moving forward, one of the architectural best practices, one of the architectural patterns that you can keep in mind while you are trying to architect for sustainability is working in a asynchronous and scheduled jobs pattern. I'm talking here about patterns similar to queuing and buffering. As you can see here, you will have your pipeline that pushes a lot of events, and you will have your business logic that wants to consume these events. And you have multiple options, either to connect your events pushing mechanism directly to your business logic. And in this situation, you will have synchronous connectivity between these two components. And this will put a lot of load on this component, in the situation of the high demand or in the peak, and it might create congestion, and it might lead also to increase the consumption of the power and to reduce the power efficiency because of your business logic services, workloads, and whatever services you're using in this layer will be requiring more, and it will think that it requires more of the resources in order to solve all of the messages coming from the event pushing mechanism. In order not to be in this loop, we always recommend considering queuing and buffering design patterns, where you can send messages from your events pushing component into an event store, which intermediates the connectivity between these two layers. And you will be able to pull these events in form of messages or queue events from this queue in order to be able to process them. However, in an asynchronous way that will help you to achieve one of the best practices in the solution architecture area that we call it decoupling, which is having less dependency between the components of your solution architecture. Moving forward, in addition to the asynchronous and queuing and buffering, we always invite you to be aware of the data patterns that you have at your organization, because implementing data classification policies and data categorization will help you to understand your data more. And understanding your data more, you will be able to use the technology, the services and the options and the feature of AWS in a better way. Let me give you an example. For example, if you have hundreds of thousands or millions of files and you want to store them at on S3, if you don't have your data classification practice and your data categorization and understanding, you won't be able to say that this is cold data, this is archival data, this is deep archival data, this is the data that I need to access instantly, this is the data that I need to access instantly. However, I'm able to reproduce this data. Why we're talking about this? Because the data classification can help you to have better storage design for your data, and will help you to develop and to design what we call it the lifecycle policies in order first to move your files between the storage classes that we have in a more efficient way, and maybe to create the lifecycle in order to get rid and to delete the unnecessary data or the data that should be deleted. This to minimize your over provisioning of the storage needed. It will help you to get rid of the unneeded and the redundant data, and would help you and the infrastructure to get rid of the unneeded and to minimize the network movement of the data across the network. And for sure, having less data, or let's say the right size of data, can help you to have the right size of the backup instead of keep backing up a whole set of data because we don't know when we might need something from it. It will be better data classification and categorization, and having a better data patterns understanding. You can have less data or the right size again of the data, and to have the right size of the backup. What do I mean with the data classification? As I said, it is our way to help you to move the data between multiple storage classes. As you can see here, we have S3 standard, which is the storage class that can help you to access the data instantly. And yeah, you can access the data instantly with high availability, durability, and scalability. In addition to S3, while we have multiple types of S3 for sure, we have S3 Glacier Flexible Retrieval, where you can have your data stored in a kind of archival storage class, where you can have your data accessible whenever you want. However, for the less or for the data that you don't really access more frequently. So you move your data from S3 to S3 Glacier Flexible Retrieval, which is a kind of archival, as I said. However, you can access your data in a kind of flexible with a flexibility. And for the data that you really know that you can wait up to 12 or hours in order to be able to access them, you can use S3 Glacier archive. How can we at AWS help you in order to reduce making decisions of moving the data across these storage classes? We have what we call it S3 intelligent tiering, which is a S3 storage class that can take care of understanding your data patterns and can help you with moving this data between the storage classes according to the usage of these files, automatically using AI and machine learning technologies. And with the zero prevention from your end, it's about just you configure the intelligent tiering, and the intelligent tiering will take care of monitoring, understanding your data patterns and movement of your data across the storage classes. Moving forward, the data access and storage patterns also play a big role. So having the right data formats will help you for sure to have sometimes the right storage options in order to be able to achieve a better storage sustainability decision. I'm talking here about, for example, using Parquet format, which is using columnar way of storing your files, using compressed files, using flat files, these types of formats according to your use case in order to reduce the impact of your workload you have. And in addition to this, you can map your data formats into a purpose-built database. The data storage options that we have at AWS are really is a wide spectrum of multiple options that we have. I'm talking here about multiple types of databases. I'm talking about databases for objects, about databases for time stream, I'm talking about databases for blockchain use cases. I'm talking about database for GraphQL. And in addition to this, we have for storing your data also as well, we have multiple options. I'm talking about block storage, file system, and object store. After the data patterns, you need to take care of the hardware pattern by minimizing the amount of the hardware that you need. The less of the hardware, the less of the consumption of the power, better sustainability and more friendly for the sustainability for sure. You can make sure that the instance types that you're using and you're considering for the designing of your workload meet the requirements of the least impact. And you can use managed services versus, let's say, infra as a service, and you can optimize the usage of your GPUs. What are the options that we have at AWS currently in order to support you with these consideration and the requirements? You can consider always the instances that meet the requirement with the least impact. I'm talking about the instance types supported. I'm talking about the instance types that supported with the Graviton processing power. I'm talking about instance types similar to R6G, T4G, IS4Gen, G5G, and the recently introduced one. It used to be up to last May, maybe I guess in a preview, and also publicly available, the Graviton 3. These type of instances provide you with the less power consumption, more performance, and more sustainability awareness for your workload and your processing and instance types. What are the services that support the selection of Graviton instance types? As you can see, two many. I'm talking about code commit, code deploy, EMR, Lambda, RDS, ECS, Beanstalk, Aurora. The majority of the services that you might consider for your workload can support. These are the services that can support Graviton. It's worth to mention that Graviton instance types support Linux operating system currently. It's always good into your architecting for sustainability best practices to consider using managed services when you are into containerization containerization practice instead of for Kubernetes clusters and workloads on-prem, you can move you can move this workload into AWS, and you can have Amazon Elastic Kubernetes Service as an Amazon EKS. If you are into Hadoop and big data processing and having this kind of distributed computing frameworks, talking about frameworks like MapReduce and whatnot, you can consider using Amazon AMR, Elastic MapReduce by Amazon. If you are into Elastic File System, you can always consider Amazon Elastic, and yeah, so on. These are the services. These are the managed services offering that you all can always consider toward having or improving your decision. Moving forward, you can also consider the development and the deployment of your workload. This is another important area to consider. So for example, while you develop and deploy your application, remember always that queues don't require immediate processing, and it increase the serialization of your data in order to flatten the utilization of your pipeline. Remember always to modify the capacity of individual component to prevent idling resources waiting for input. A lot of best practices, for example, scheduling tasks in order to be able to avoid load spikes. Schedule jobs, during the times of the day where carbon intensity for power is lowest. And these are the type of the consideration for this. As an example that I would like to pick here is AWS for JavaScript, which is used almost wherever a browser or Node.js code calls an AWS set. And this, as you can see, version 3 of the AWS SDK for JavaScript introduced modular packages per service, and it can help you to reduce size by 75%, and it can reduce the installation and the publication size by 50%. Again, less resources, less power consumption, less storage, less networking, less processing needs, and for sure more sustainability friendly solution architecture. Sorry. Another best practice that we invite you to do is, or a pillar, is to start with your sustainability goals and move backward instead of moving from left to right, conceptualizing, designing, implementing, and staging, then producing your workload, then asking yourself how my workload is compatible with my sustainability goal. We invite you to start always by your sustainability goal and to move backward so you can conceptualize, design, implement, and stage your solution and your workload aware of your sustainability goals. And it would be also better to have your sustainability also revised and checked and visited at every stage in a continuous way and an iterative way. I'm going to move to start talking about what we call it the proxy matter. How can I know the details of my sustainability practice? What type of metrics that are available at AWS? So the type of metrics that we can provide you are about the cost and the usage. And I believe that the cost, having insights about cost reduction is a huge motivator in order to be more sustainability friendly into designing your solution and architecting them. Pillar is the itemized usage that you can get from CloudWatch metrics. So for example, if you would like to get the metrics of your workload, you can always remember to divide the AWS usage metric over the unit of work. And with this, you can get the workload metric. For example, if you have this and as you can see here, the predicted path of your workload, as you can see, this is your usage, this is the workload itself, and this is the metric because we're dividing this over this. And if I move forward, the less the usage that you have, with more work you have, the less the metric value you would get as a result of this reporting. Now, being conscious about the time, I still have only a few minutes. How can you get started? First of all, the foundational steps that we recommend you to consider are: implement a data classification policy, use lifecycle policy to archive and remove the unneeded data, scale your infrastructure by user load, and always consider automation while looking into the scope. Automation will help you big time into scaling your infrastructure in a responsive way instead of manual way. Use the minimum amount of hardware to meet your needs, and use managed services. So less hardware and use managed services, and always consider visiting and viewing your customer carbon footprint tool. The tools that can help you through this journey are Amazon CloudWatch, your metrics tool in order to extract metrics and to understand them. Use S3 storage lens that can help you to get a cross account insights of your S3 data. Trusted Advisor that can AWS Trusted Advisor analyze and recommend you with the best design and advices for your workloads. Compute Optimizer that can tell you about the overutilization, below utilization of your resources, and for sure back to the AWS well-architected tool, which is the tool on the top of the AWS well-architected framework that can get questions related to your workload and so on. Consider always to visit the well-architected sustainability pillar, the labs, the sustainability game day, the AWS blogs of the sustainability. In summary, the sustainability use cases, the carbon footprint, the well-architected sustainability pillars, the workload metrics, and define your next step. With this, I come to the end of my presentation. I hope that you found a value out of it, and I hope that I was able to give you some good idea about how to design and how to solution architect your workloads with sustainability in mind under what we call it as architecting for sustainability. Any questions? Happy to answer.